today's seminar, and we have been having a series of seminar where we invite an expert in the field. So last time we had an expert in electronics, embedded electronics, and today we have another expert from the aviation industry. Her name is Engineer Halima Sevingi. So she's been doing a lot in electronics, and she's been sharing with me lots of news in aviation. She has a passion in avionics, specifically avionics. And today she's going to share with us her journey to become avionics engineer. So Engineer Sevingi, you are most welcome. Please meet students from University of Dar es Salaam, Department of Electronics and Telecommunications Engineering. Though I believe we might have some other people, people from other universities, because a link was broadcast to other the social networks issues. So I believe we might have some people from other places. They keep on joining, but I think you can just start.
Okay, thank you very much. As you have introduced me, my name is Engineer Halima Rashid Sevingi. I work with Air Tanzania as an avionics engineer. I have a license in aircraft maintenance engineering under TCAA, which is in category X. As you said, I'm a graduate from the University of Dar es Salaam, and I did the Bachelor of Science in Electronics, Science and Communication. I will take you through the successful journey towards the avionics engineering. And I'll tell you more what do the aviation industry wants. I hope everyone is ready. Okay. The outline, I'll have the introduction.
Engineer, you can put in slide mode. Can you press that button of slide? The slide mode at the bottom of your slides.
That one?
Yeah.
Or the other one, this one?
No, the other one.
This one.
Yeah. Yes, that one.
This one, eh? Okay. So I'll take you through the successful journey towards avionics engineering, as I said. Course or the discussion, we will have the introduction. And the introduction part, I will introduce you to the machine first to know the machines that we are working with. Take you through the components of the machine. There's some systems in the avionics part. The aviation and avionics, I'll tell you more about. Okay, thank you. So as part of the introduction in the avionics systems, first, this is the machine that flight to fly. And on the aircraft, there are two things that you need to know. We have the fixed wings aircraft and the rotary wings aircraft. The fixed wings are like the normal airplanes that everybody knows, and the rotary wings are the helicopters. Now, through the basic aircraft components, we have the fuselage. We have the fuselage. The fuselage, this is the hollow part where it holds the wings, it holds the tail part of the airplane. It holds the power plant, the landing gears, and the wings. So the fuselage combines the cockpit and the cabin in the interior. In the exterior, we have the empennage, the wings, the power plants, and the landing gears. On the cockpit, that's the space usually enclosed in the forward fuselage of an airplane, where we have the flight controls, the instrument panels, we have the switches, the knobs, and the seats where the pilot and the co-pilot or the flight crew sit. Basically, we have two types of the cockpit. We have the glass cockpit and the instrument cockpit. The one displayed is the instrument cockpit. The instrument cockpit is called the instrument cockpit because the pilot sees everything in the instruments. You have the altimeters, the airspeed indicator, the vertical speed indicators, the artificial horizon. Every system or every unit is in this. It's in its own instrument. But the glass cockpit, we have the computers or the displays. The display can display all the systems in one unit. So the pilot don't have to observe in different instruments to see his parameters of flights, or to see his altitudes, or to see the airspeed he's using. Everything is displayed in the computers. We call them the primary display computers and the multifunction displayed computers. So as part of the fuselage, I said we have the cockpit and the cabin in the interior. The cockpit is where the pilot and the co-pilot sit, and the cabin is where the passengers sit during flight. So in case you have any questions, you can just write down and I can explain more if you want more elaboration on the part I've passed through. The second part, I said we have the power plant. On the power plant, okay, sorry, what is this? Hello, I can't hear a sound in the meeting. Oh. Somebody cannot hear me. Oh. Anyone else who doesn't hear me?
Yeah, I think we can hear you.
Okay.
Yeah. Okay.
So back to the power plant. As I said, the power plant, this is the heart of the aircraft. It's the part that provides power and thrust during flight. Here comprises of the engines and the propellers. The aircraft engine is the component for propulsion system for an aircraft that generates mechanical power. And the aircraft engine can either be the lightweight piston engines or the gas turbine engines. The piston engines is as the one seen here. The mechanism or the operation of the piston engine is almost the same as the engine of your car. We have the pistons, the cylinders. The very same mechanism is the very same mechanism providing power on the plane for the piston engines aircraft. We also have the gas turbine engines. On the first display here is the jet engine that doesn't have the propellers. Mind you, we have the engines with the propellers and the others have just turbines without propellers. So the first image here is the jet engine, which is part of the gas turbine engine. And the second image here with the propellers, this is the prop or turboprop engines, which is also a gas turbine engine. So we have the piston engine aircraft, mainly in the small, very small aircraft, 6 passengers up to 8 passengers have the piston engine, but the big aircrafts mainly are the gas turbine engines. So in Air Tanzania, the planes that we have all are gas turbine engines. We have the turboprop and the turbojets, but they're gas turbine engines. So before I proceed, there is something I need to tell you so we can move forward together. We have the 4 forces of flight. We have the lift force, we have the drag. We have the lift, we have the weight. The lift, the opposite of the lift is the weight, and we have the thrust, which is the forward movement of the plane, and the opposite of it is the drag. So all these components of the aircraft are designed to give us or to maintain those 4 forces to facilitate or to accelerate the plane to fly. So coming back to the fuselage, I missed this part. Coming back to the fuselage, the structure of the fuselage is like a hollow or a cylinder, long cylindrical tube. That shape is designed to allow air flowing to allow the aircraft to fly. And the structure of the wings also are in the aerofoil shape. That aerofoil shape also facilitates lift. The engine now, coming to the power plant. What the engine does is to give the forward movement of the plane. So to generate that, and the forward movement is what we call thrust. So we use the engines to give the thrust or the forward movement of the plane, whether it's during cruising, when the aircraft is already up flying, or during taxiing, when the aircraft is on ground. We use the engines for forward movement or for the thrust. Okay, so the engines give us the thrust, the fuselage allow us for the lift. We also have the wings as the main component of the aircraft. Wings, they provide lift force for flight and carries fuel tanks. On the wings, most of the airplanes, the wings is where the fuel tanks are. We fill the fuel on the wings. At the wings inside, we have the fuel tanks. In other types of aircrafts, we have the fuel tanks on the center part of the fuselage, just below the stomach of the plane. The wings are huge. We have the flaps at the back of the wings to accelerate or to facilitate your lift. The shape of the wing itself cannot give an adequate force for lift. So to regulate that, we have the flaps, which we can extend or we can retract them to a certain angle that is comfortable for the plane to fly. We also have the empennage as the 4th basic component of the plane. The empennage is the rear part of the tail assembly of the fixed wing aircraft. Speaking of the fixed wing aircraft, if you remember, I said before, we have the fixed wing aircraft and we have the rotary wing aircraft. The fixed wing are the normal aeroplanes we know, that they have their wings fixed. They're not moving, the wings are there. And the rotary wing aircraft is the helicopters. The helicopters, the wings rotate on top of the aircraft to accelerate or to support lift. So on the aeroplanes is where we have the empennage, not on the helicopters. On the empennage, this is the rear part of the tail assembly of a fixed wing aircraft. It includes the vertical and horizontal stabilizers. The vertical stabilizer is the top part of the tail where we have the rudder, and the rudder is used on steering. And just below the rudder, we have the elevators. I will show you on the previous design. If you can see the tail, we have the long red part here. This is the rudder. This is the one that gives us the steering. You can steer to the left, you can steer to the right. Just below the rudder, we have the white, small wings. This we call them the elevators. The elevators give us the pitching nose down, pitching nose up. You want to take your plane to fly, you have to pitch nose up. So it's the elevator that does that. Okay. So I already speak of the empennage, where we have the horizontal and the vertical stabilizers. Then the fifth main component of the aircraft is the landing gears. The landing gears support the aircraft while on ground. This plays a very crucial role on the aircraft movement when it's on ground, during taxiing, takeoff, and landing. Without the wheels or without the landing gears, the airplane could land with a stomach, which could not be good. So to have a safe landing or safe airplane or aircraft on ground, we have the landing gears. Are we together up to there?
Yes.
Yes, yes.
Thank you. Okay, now I'll take you to the part 2 of the introduction, where I'll share with you some avionics systems of the plane. I'll start with the aircraft radio systems. For the airplane, or for the pilot to take the plane to a certain point, he needs to communicate with the towers. He needs to communicate with the other airplanes. He needs to communicate with the the operation department of his operators. There are so many parts that the pilot needs to communicate, because he can't see everything when he's on the plane. So we need the aircraft radio systems. On the aircraft radio systems, the system is the same as the radio system you know. The radio system we are studying in college is the very same mechanism. Much of the aviation communication is accomplished through the radio waves, the very same radio waves we use in the microwave communication, but here we have different frequencies. So we have the VHF communication, the very high frequency communication, to which via the VHF, the pilot communicates with the tower, the pilots communicate with other aircrafts, the pilots can communicate with the people on ground. That's through the VHF. Then we have the DME, the distance measuring equipment, where the pilots can determine the distance he is before landing. Then we also have the GPS for global positioning system for the plane's position. We have the radar altimeter. The radar altimeter gives us the altitude, the actual altitude. It sends signals to the ground, and the signal gets back to the plane, and it can measure the distance in between, the height in between. So that's the radar altimeter. We also have the weather radar to give the pilots the navigation to see the weather condition during flight, because the airplanes can fly at night, you don't see anything. So we use the weather radar to determine the weather condition ahead or in the flight path. And so many other systems in the radio communication where it's used on the planes. Okay, this is just the basic transmitters and receivers, the very same one we are taught in school. So there is nothing new if you have the basic of what the system works, or the basics of the radio communication. This is very easier for you. Okay, I just kept the pictures of the antennas, some of the antennas, the weather radar antennas, the VHF communication antennas, the transponder. I haven't said something of the transponder. The transponder gives the tower the altitude of the plane. The control tower can get the altitude of the plane by the transponder antenna. So I just kept the images of some, not all, some of the antennas we have in the plane. And the system, as I said before, the system or the aircraft radio system operates the same as the normal radio system we are studying in school. you need to have the antennas, you need to have your transceivers or the transmitter receivers. So the signal is sent, is received at the other part, is sent by the antenna, is received on the other part, and the signal is sent back to the receiver. It's the very same system or very same mechanism is applied. Then I'll take you through the flight controls. This is one of the most important system on the airplane. The flight controls give the attitude of the plane. The plane needs to move forward. The plane needs to steer to the left, steer to the right. The plane needs to roll to the left, needs to roll to the right. The plane needs to pitch nose up during lifting or takeoff, and needs to pitch nose down during landing. So we really have these flight controls, which plays a very important role in controlling the whole of the flight. We have the primary flight controls, the aileron. The aileron is fixed on the wings. The aileron is part of the wings, and it gives the roll of the aircraft. It gives the roll to the left, rolling to the right. So if the plane needs to roll, the pilot controls the rolling by the ailerons. The ailerons are fitted at the back of the wing. The yellow thing here on the first image, the orange part, sorry, is the ailerons. Then we have the elevator. The elevator is the blue part here. The blue part here is the one now that gives you the pitching nose up, pitching nose down during takeoff, during landing. This is the elevator. Then we have the rudder on the tail here at the back, the green part. The rudder steers the plane to the left and to the right. We call it yawing. It yaws to the left, it yaws to the right. Then we have some other secondary flight controls. See the second image here. We have the flaps. I said earlier about the flaps at the back of the engine. At the back of the wing. The flaps give the extension of the wing. At times during takeoff, we need to fly at lower speed and yet to get high lift. So to generate that, we use the flap. You extend the flaps so the wing surface is larger and you get enough lift at lower speed because you cannot take off at high speed. We have the slats in front of the wing here. We have the spoilers. They all play that same role of the wing in generating lift. Okay, if you have any question, I would like I'll read it and I'll answer you right on time. Okay, I'm going to the other system, the aircraft electrical system. As part of the avionics is all about radios, about electrical, about navigation, about instrumentation. All those parts are parts of the avionics. So the aircraft electrical system is the primary function of an aircraft electrical system. And it generates, regulates, distributes electrical power throughout the aircraft. And we have some sources of power in the plane. In the aircraft, we can get the power from the batteries, the aircraft batteries, which we have. The batteries are mainly used for emergency. We don't use the batteries throughout because the batteries can drain, and we need to have an alternative source of power when we have any power failure. So the batteries are part of the emergency power source. We also get power from the ground power unit, which is installed or is connected on the plane when the plane is on ground to give power. The ground power unit can have its own battery, or it can be getting power from the generators, or it can have power from the main building power source. That's the ground power unit. The ground power unit. We also get the power, or another source of power in the plane is the generators. Each engine has its own generator. The generator gives power to the plane it gives power during flight. When the engines are start or when the engines are running, is when you have power through your generators. So basically we have three main sources of power. Oh, sorry, another source of power is the auxiliary power unit. It's a small engine installed at the back of most of the planes, and this gives power during ground. We need power during ground. During flight, you use the engines, but during ground, on ground, we use the auxiliary power unit as the source of power. So basically we have about 4 sources of power in the aircraft. One is from its main engine generators. Second one is from the batteries as part of the emergence. Third one is the auxiliary power unit. And the fourth is the ground power unit that is connected while the aircraft is on ground. So as the image shows, I just picked some pictures of the generators. This is the starter generator used on the plane. I say starter generators because in one unit we have the starter, and yet we have a generator in that very same unit, but they operate separately. The starter starts to start their engine. Then after the engine reaches its satisfactory RPM, the generator picks up and the starter circuit cuts, so starts generating power for the aircraft systems. Then we have the batteries. Here I just show some of the batteries in the workshop. Then these batteries are installed on the plane and they're used during emergence. Here is the auxiliary power unit, which is the small engine installed mainly on the tail of most of the planes. And the fourth diagram here, the fourth picture here is of the ground power unit. I say this is the unit that is connected when the aircraft is on ground. It can be using power from its own generators or its own batteries, or it can get power from the main building power source. As you can see, this is connected to the plane, but the auxiliary power unit is installed as part of the plane. The generators are part of the engines, and the batteries are part of the plane. You install the batteries for power source during emergence. Okay. We are done with the introduction part. If there is any question or there is any concern, I welcome you for that before I move to the aviation and avionics part. Dr. Baraka. Hello.
Hello.
Yeah, I welcome any questions or concerns or on the introduction part. Does every engine have its backup batteries? Okay, the backup batteries are not installed on the engines. On the engines, we only have the generators. The batteries are installed separately as part of the emergency power source. So and they're not installed on the engine. They can be installed on the part of the fuselage or anywhere, but provide power in its own buses to the systems. Did I answer your question correctly, Amos?
Yes, you've answered it.
Thank you. Any other question? Okay, we'll proceed. If you have any question, you can just keep it and I will answer it at any time. You just share it here. I will answer the question. We are moving to the second part. What is aviation and what is avionics? Aviation, this is the Latin word coming from the word avis, meaning bird. appropriate translation, given that aviation deals with travel by air, specifically travel in a plane. The aviation industry is the business sector dedicated to manufacturing and operating all types of aircraft. All type of aircraft. So, aviation. This is the, sorry. Okay, aviation, as I said, it's broad, it's huge, but all in all, aviation deals with the manufacturing of the aircraft, deal with operation of the aircraft, dealing with maintenance of the aircraft, and everything to do with the aircraft. We call the aviation industry, or we call it aviation. From manufacturing to operating. Through operating is where the maintenance part comes in. Then we have the avionics. Now, avionics, this is the blend of the aviation and electronics. We have, before I go to avionics, aviation is broad. It has the maintenance part. The maintenance part. Okay. What is the source of auxiliary power unit? Okay, for auxiliary power units, this operates the very same way as the engine. It's a small engine installed on the plane. It's the small engine installed on the plane, and this engine operates the very same way as the main engines of the aircraft. It has its own starter generator to start the engine and the generator to produce power. To answer the previous question, the top one from Domele, what is the total output power of the GPU? Our aircraft runs with a DC and AC power. Under DC, we use 28 DC voltage. And AC, mainly we have 115 voltage of AC or 26 VAC. So your GPU depends. If it's an AC GPU, then it has to give you the 115 VAC. And if it's the DC ground power unit, then it has to give you the 28 voltage to supply the aircraft systems. Okay. I hope I've answered your question correctly. Yes, Nomele.
Thank you.
Okay. For the transponders, how are they communicate with the ground station? Okay. The transponder, as I said before, it's an antenna and the transceiver. It's actually a complete radio system. It has its antenna and it has its transceivers. What the tower does, the transmitter is inside the plane and the receiver is inside the plane. And we also have the transmitter at the ground control unit or the tower control unit, and the transceiver as well on the tower control unit. How the system works is, before the plane takes off, the pilot switch on the transponder and the tower will give him the frequency to communicate. So via that frequency, the control tower can read the plane and yet the pilot can communicate with the tower. That's how the communication between the control tower and the plane works. So you have the transmitter receiver in the aircraft, you have the transmitter receiver in the ground control unit, and the antenna is installed on the aircraft. So the information is transmitted, received to the tower, and the tower transmits and received to the aircraft. Did I answer that correctly? Prosperous?
Yes. Thank you.
Thank you very much. Okay, now let's proceed. Okay, I said before I go to the avionics part, I will tell you the other part also. Aviation or the maintenance is not only about the avionics. We also have the mechanics. We also have the mechanics part. we call it A and C, airframe and engine. C stands for the engines or the power plants. This is another category or is another part of the maintenance engineering. So in the field, we have the avionics engineer and we have the mechanics engineers. The mechanics engineers deal with the airframe. The airframe means the structure of the plane, the wings, if you have any problem with the fuselage or the main landing gears that don't involve the electronics parts. That is covered by the airframe engineers. Then the engine engineers cover the maintenance part on the engines. So that's the second part of the maintenance. Then our part or my part where I work is the avionics now, the electronics part. I do all the maintenance on the electronics part of the plane. Everything to do with electrical, anything to do with radios, anything to do with instruments, anything to do with autopilot is under avionics. So avionics, this is the blend of aviation and electronics. Okay, in the communication process, is handover process taking place? I'm curious on the distance of communication between the tower and the plane. Okay. The handover, no. But on the distance, we have not one antenna or not one radio system to operate. The system works in different subsystems inside. So the distance is not the problem because the plane flies at very high altitudes and the tower is just on the ground, but the communication is very accurate and rightly on time. The frequencies set are sent for accurately covering the distance, covering the delays and all that. So the system in this part, I don't know how to put it, but the distance is not it's not a problem. It's not a problem at all. Did I answer that? Amos?
I'm sorry. Yes.
Hmm?
Sorry. What I just wanted to know is,
Yeah.
so maybe the plane is from Dar es Salaam to Dubai.
Okay.
So it means that the plane will only communicate with the same tower, which.
Okay. I get your point. No. As the plane is moving, okay, now I get your point of the handover. Yes. As the plane is moving, as you're leaving a certain part of the a certain place, not just even a country, a region, you're moving from Dar es Salaam Tower to Zanzibar Tower, you hand over to the minute Dar es Salaam Tower hands you over to the Zanzibar Tower, and it goes as that way until you reach your destination. You're not saved with only one ground control tower. So as you move to a certain to another point, you hand over the tower hands you over to another control tower. And once you pick that control tower, you acknowledge the previous one, so he knows that you're already communicating with another one, and he'll give you a different frequency to communicate with another control tower. Like for example, in Dar es Salaam, we are on ground, it's 121.5, but in Arusha, it's a very different frequency. In Zanzibar, it's a very different frequency. So the handover is done. I didn't get your point of the handover. Okay, the handover is there. Did I answer that?
Yes, thank you.
Okay, thank you. So we proceed. Okay, I'll speak more on this part before I go to the second part of who is an aircraft maintenance engineer. Okay, in avionics, as I said before, in aviation first, we work under regulations. We have the regulations that governs our operations. I'll give you a brief introduction of where our regulations come from. During the Second World War, the planes and the aviation almost collapsed. So some great countries decide to have a meeting or a convention to discuss on how to build the aviation industry. Then the meeting was held in Chicago and it's called the Chicago Convention. After this meeting, I would like you to go through, on the internet and read about the Chicago Convention. The Chicago Convention was the meeting where they agreed on some regulations, some policies to run the civil aviation. Civil aviation, we have two different types of aviation. We have the military aviation and we have the civil aviation. The military aviation operates in its own regulations that don't concern us, but the civil aviation, where we have the airlines, the general aviation, this part, we work under civil aviation. So with the civil aviation, we have the authority. Previously, first, on the Chicago Convention, we had the ICAO, International Civil Aviation Organization. The ICAO organization needs to communicate or needs to provide regulations to run the civil aviation worldwide. So to make it easier for them, each country or each member state of the Chicago Convention need to have its own authority that will adhere to the regulations of the ICAO, which are the regulations of the International Civil Aviation, of the Chicago Convention. The Civil Aviation Authority in Tanzania is TCAA, Tanzanian Civil Aviation Authority. The regulations are made under the parliament, the very same way as other regulations of the country, but all the regulations are made adhering to the regulations of the ICAO. ICAO gives us the standards and recommended practices that we need to follow. We have the annexes that we formulate the regulations from the annexes, and these regulations are the one we use in the civil aviation in Tanzania. So now, aviation parts in Tanzania, like the current regulation, which is going to end in 2027. According to the current regulation, the avionics part or the avionics engineer needs to do 5 parts of the maintenance or the aircraft maintenance in the plane. The first one is the electrical part. The second one is the radio part. The third is the instrument. The fourth is the autopilot. And the fifth is the compass. This is according to the current regulations that is operating now until 2027. When it reaches 2027, we'll have another regulation that will only give you B1 for the mechanical engineering and B2 for the avionics engineering. So the B2 will be like just one category category B2 avionics. The B2 will comprise all these 5 categories into one category. So currently, before 2027, we are using each category separately. The electrical separately, instruments separately, autopilot separately, radios separately, and the compass also separate. So the avionics engineer, okay, this is in the next slide. I just wanted to make that clear before we proceed to the third part of who is an aircraft maintenance engineer. Is there any question on the aviation and avionics? Why during the flight it is recommended to put the phone in airplane mode? Okay, this is a very good question. In flight, it is recommended, really recommended to put your phone in airplane mode because the plane needs to communicate. We need clear communication between the pilot and other ground operators or the control tower or other moving aircrafts. We need clear communication. So to avoid interference with your phone seeking for the signals, we recommend you to put your phone in airplane mode so we can reduce the interference. We don't need any interference during flight communication. That's the main reason why you're told to put your phone into airplane mode. Did I answer that question correctly, or did I meet your expectation, Deus?
Yes, yes, madam.
Okay, thank you very much. Okay, before we proceed to who is an aircraft maintenance engineer, is there any question on what is aviation and what is avionics? We all good on that part? Okay, thank you. Then now we are moving to the third part of this presentation. Who is an aircraft maintenance engineer? An aircraft maintenance engineer is the person who is responsible for ensuring that aircrafts are well maintained, aerial vehicle is airworthy. We need the plane to fly safely. Like the very same way you do service to your cars, it's the very same way we need the airplanes to be done or to operate safely. In case you have anything that needs repair, an aircraft maintenance engineer is the one who does the repair. In case you need inspection to see if there is anything wrong with the system or with the plane, it's an aircraft maintenance engineer who does that. The maintenance, scheduled and unscheduled maintenance, are done by the aircraft maintenance engineer. So aircraft maintenance engineer is our, aircraft maintenance engineer professionals are responsible for maintaining, repairing, overhauling, and ensuring that the aircrafts are safe and airworthy. Airworthy. Airworthy is the term that is commonly used to show that the plane is safe to fly. The field related to aircraft systems, the maintenance procedures and regulations. Everything done in the maintenance in Tanzania, we follow the regulations. You just don't do things from your brain or from your mind. You see what the regulation tells you and you follow what the regulation tells you. So basically, TCA provides licenses in various categories, but mainly the field is divided into 3 categories, as I said before: the engine, airframe, and the avionics. So we have 3 types of engineers in the maintenance part: the engine engineers, the airframe engineers, and the avionics engineers. Okay. So in this field, in the maintenance part, we have different types of aircraft first, and each type of aircraft, the type I mean, like maybe the Boeing 787-8 Dreamliner, this is one part of the aircraft, and one type of the aircraft. Another type, maybe the Boeing 737 MAX, or it could be the Airbus A220, or it could be a Cessna Caravan 208. These are the types. Each type of aircraft has its own manual. When you buy the aircraft from the manufacturer and you bring it here to operate it, you are given the manuals, the main type manuals. From that manuals, the manual will lead you through your maintenance. Everything you do on the aircraft is written on the manual. So you go to school like what you're doing now in college or in the university to give you the basics of what needs to be done. But what needs to be done in this field does not come from your brain. You have to follow the manuals. What the manual tells you to do is what you do. So if you have a problem, let's say you have a snag on a certain system, the system is not operating correctly. What you do, you refer your manual, you write to your manual, you speak to your manual that my aircraft does not do this and this and this. Then the manuals will tell you, open this, do this. If this does not work, then do this. You will follow the guides from the manuals. So everything we do on the maintenance part of the aircraft is followed from the manual, not from our heads. From your head, you'll only have the basic, like this system is not working because of this and this and this. So you have the starting point of the troubleshooting. But everything from the maintenance to the inspection to the repairing is done according to the manuals. And the TCA now, the Tanzanian Civil Aviation Authority, leads or come to see if you really follow the manuals during your maintenance to show that you are adhering to the current regulation and you follow what the ICAO wants and you follow what the manufacturer of that airplane wants. So everything in this field is done according to the manuals. So you have the aircraft maintenance manuals, you have the minimum equipment list, which is also part of the manual. The minimum equipment list will tell you the aircraft is safe to fly with a certain deficiency of a certain equipment or a certain unit. If a certain unit fails, the minimum equipment list manual will tell you that the aircraft is safe to fly with this system fail, or the aircraft cannot fly with this system fail. So if the aircraft cannot fly with this system fail, then that aircraft is AOG, aircraft is on ground. It cannot fly until that snag is rectified. So that's the part of who is an aircraft maintenance engineer and what does the aircraft maintenance engineer do? Is there any question on that part? Because this is the most important part of the field or of our discussion today. I would like to answer more questions on this part. I welcome you for the discussion, please. I would like to hear more questions from you or any concern of who is an aircraft maintenance engineer and what does the maintenance engineer do, and any other thing that you feel like we need to discuss about it. Anyone? Thank you very much, Amos. What are the requirements of an aircraft maintenance engineer? To become an aircraft maintenance engineer, first you need to have your basic undergraduate course in the it can be in the aviation part. You can have your degrees in aviation, to which in Tanzania it's only in NIT, the National Institute of Transport, that provides the aviation engineering course. You can have aeronautics course abroad. Also, you can have a mechanic degree from a recognized institution or university. You can have electrical or electronics, the same as I do. And that is the basic, the very first basic thing to become an avionics or an aircraft maintenance engineer. Then from having your degree, not necessarily a degree, guys, you can also have a diploma, but from the diploma, the journey is a bit long, but it can also lead you to that point. But if you have a degree, is important, is good. Then from having your degree, coming to the field now. In the field, if you have a background of the aviation, like you went to aviation school, with TCAA, you'll only need 2 years of working experience to start your TCAA examinations to make you qualified to become an aviation engineer. But if you don't have the background of the aviation, like I do, I only did electronics. If you don't have the background of the aviation, you need 4 years of working experience or on-job training. Then after that, you qualify to go for the TCA license exams. If you pass the license exams, TCA will give you a license to recognize you as an aircraft maintenance engineer. Then thereafter, you can start working, or that's the first step. You become a maintenance engineer. But that's not enough, because to become an aircraft maintenance engineer, you're supposed to release the aircraft back to service after a certain maintenance or task is done on the aircraft. To release that aircraft, you also need another type course training on that particular aircraft or aircraft component. So the type course is given by the manufacturer of the airplane. So the manufacturer will give you the type course. Then if you pass the type course training, then that's another step to start releasing the aircraft back to service after the maintenance or inspection or repair is done on that plane. Having the type course and you pass, before you release the aircraft to service, you do again the on-job training to get the approval under TCAA again to allow you to release that aircraft to service. So here is like there are 4 or 3 steps to become a qualified licensed aircraft maintenance engineer. The first thing is your degree in electrical, electronics, even telecommunication, aviation or aeronautics. Then from there now, you work in the field for a number of years, 2 years if you have a background of aviation, or 4 years if you don't have the background in aviation. Then after 4 years, you go to do your TCA examination for your license. After you get the license, then now you need to release the aircraft to service. But you cannot release the aircraft to service with just that license. You need to have a type course training on the specific aircraft type design. Then after having that training and you pass the training, you have again an on-job training. It can be 6 months or up to 1 year of on-job training on that type of aircraft. Then thereafter, TCAA will give you an approval to release that aircraft back to service. Okay, so that's the journey to become an qualified or licensed engineer. Okay, another question from Dombele. Did you get further education after your degree? Yes, but it's not a master degrees. I didn't go for my master's. I'm planning to do my master's, but in a different field. After my degree, I followed that path I said. I did my 4 years of working in the approved maintenance organization. Then after the 4 years, I went to TCA and I started doing my avionics examinations. I did the electrical, the instruments, and the autopilot, and I got my license. And now I have to go for the type course training, to which I'm planning to go for the 787 Dreamliner course. Maybe it should be on this September. Then thereafter, I'll have to work again for 1 year or 6 months to get my approval to become a certifying engineer. We call it certifying engineers in Boeing 787 Dreamliner. Currently, I'm working with the Q400 Bombardier. I have a type course training on that. So I released the Q400 Bombardier. I'm not doing the 737. I'm not doing the Airbus as releasing it, but I work on them also. So I'm planning to go for my 787, I think, on September. Okay, I think I've answered you, Nomele. Coming to Isaac Mwasalemba. As an aircraft maintenance engineer, you need to get a specific to certain kind of airplane, or do you do in any plane with the same basics? Okay. In the field, we have the sorry. In the field, we have the okay, sorry. Can I give you 5 minutes break before I answer all these questions? So at least you can refresh with what I've given you before I come and answer Isaac Masalemba, Deus, and others. I'll give you 5 minutes break. Eh? Are we good? Prosperous, please tell me, should I give you 5 minutes break?
You can continue.
Okay. Sorry.
Yeah.
Okay, so as the aircraft maintenance engineer, do you need to get specific certain kind of plane? Yes, you need to have a type training course on each type. But before you go for that, you do maintenance using your same basics in all other aircrafts. The type course training will give you the access to release the aircraft to service. But if you're not releasing the aircraft to service, that means you can work as a normal engineer to do the maintenance, the repair, inspection, etc. But you will not be allowed to release that airplane or airplane components to service. So another question from Deus, what are the risks to consider? Among the critical fields, I think, is the aviation industry. The maintenance part is very critical. Safety is #1 key. Yani, we will have to make sure everything you do, you have, how should I put it? You have to consider each and everything. And every 2 years, we are doing the recurrent calls in the human factor, risk management, safety management procedures. It's part of the aviation. We take risk, and here we don't have second chance. So your first chance, you have to use it effectively. There is no second chance in the field. So we have so many risks to consider under your maintenance, but make sure you follow your manuals. When you follow your manuals, you're on the safe track. You don't follow your manuals, my friend, it's going to eat on your side. You really have to follow your manuals. You really have to follow the regulation, what the regulation tells you. You need to follow the safety keys. You have to work with your safety manual in your brain. The moment you step into the hangar or to the line maintenance facility to the time you step out, you have to work with the safety maintenance manual in your brain. So there are a lot of risks to consider. Okay. Sorry, can you please repeat the questions? Can you really please repeat the questions? Deus, I remember you had a question. And some other people, please repeat the questions. Okay, as we saw in the plane, there are almost 5 various types of radios. Shouldn't we read radio engineers or this instead of avionics engineers? Okay. Yes, Alfred. Okay. Okay, you said we have almost 5 various types of radios. Okay, I think the radio communication we are doing in school is enough. Is really enough in aviation, because we only need the basic of the radio engineering, just the basic, the transceiver, receivers, transmitters, receivers, the antennas. That's the basic. That's the most basic part of the radio thing. So I think the one we are studying the microwave communication. I don't remember the other communication parts we are reading, but the very same basics of what you're studying in school is enough in the maintenance. Because here you only need the basic, and how the systems work, you will learn in the type course trainings. Okay. Another question from Deus: what are the risks to consider during aircraft maintenance? Okay. There are so many risks. I don't know how I can put this, but there are so many risks to consider. We take everything as a risk in this field. We take everything as a risk. So, and as I said, we don't have the second chance. We only have the very first chance. So you need to use the first chance with proper safety measures. We don't need the plane to crash. We are the one releasing the airplane to fly, so we don't need the plane to crash. We don't need to have any problem during flight. We need to have a safe flight. So to make sure we have the safe flight, the key thing to do is to follow your manuals and your regulations. Your manual and your regulations. That's the basic thing you can do. And every day you have the risk assessments and measurements to take. So it's part of the field before you join or before you start working on the plane. You'll be taken through the various risk assessments and measures to take during maintenance. So on the risk, there are lots of risks to take, to consider during maintenance. Okay. What are the risks? Okay, one can easily listen to pilot control tower communication. Why do you guys leave the channel unencrypted? Isn't this a threat? It's not a threat. It's not a threat. And it's not everyone can listen. It's only when you have access to listen. And how should I put it? One of the safety means of transport, I think, is the air travel. everything is controlled. This aviation security is huge. So everything is controlled, and I don't know, but it's not everyone who can listen to the communication. It's people are people that are supposed to listen will listen. Like the aircraft maintenance engineers, once in the plane, you can hear what the pilots communicate with the tower, and yeah, I don't know how I can put it, but speaking of a threat, the aviation security consider, I think, all that. I'm not sure if I've answered you, Ndomele, correctly.
No. Sorry.
No.
The question was not the communication actually, it was the ADSB signals. As we know, it's not encrypted.
Okay.
Yeah. What the system does, it emits the plenty information like where am I right now, my speed, my bearing, what am I calling now, my call sign. What if someone tries to use this information like to hijack the plane, since he knows the I may say the vital information for aviation. Yeah, that was my question.
Okay. Okay. I'm trying to think of how I can answer this correctly. But I said before, we have the aviation security team. And this information, the information between like where the pilot is, what does he do, that information is only shared with the control tower. So if any information is leaked between the pilot and the control tower, then I think the aviation security guys will have to work on that part effectively. But otherwise, the communication between the pilot and another pilot is only what that pilot have determined to give to the other pilot. Otherwise, the other pilot will only know I have a difference of certain altitude from this plane to this plane, which is good so that they cannot collide, and other information unless the pilot shares with the other parts. But the clear communication between the pilot and the control tower about where the pilot is or where the plane is, I think the aviation security have considered that well. We don't do anything on that part. I can't say much. Okay, we have another question from Judith. In Tanzania, do aircraft maintenance engineers use AI tools for maintaining and repairing? No. We don't use artificial intelligence tools, my friend. All we use is the manuals from the approved or from the manufacturer. So we cannot use, and it's not allowed to use the AI tools. It's not allowed at all. Additionally, is it possible to encounter challenges that the aircraft manuals can't solve? What actions would be taken in such cases? Of course, we get the challenges that the aircraft manuals do not solve, and what we do, we contact with the manufacturers. Everything you do on the plane, the manufacturer needs to have the information of what you're doing. So if you have a problem that you know this problem, the manual cannot do it, and I cannot troubleshoot any further from the knowledge I get from the manuals, then you contact the manufacturers, and the manufacturers will give you the way forward. So we really get the challenges that the manuals cannot solve. It's normal. So you try figure it out. You can share your ideas with the manufacturers, and the manufacturers will give you the go ahead. Like what you're thinking is right, go ahead, do it. Or it will give you, the manufacturer will give you another means of solving or dealing with the issue you're facing. Is that okay, Judith? what were you doing in getting a 4 years job experience? Okay, in every company, before the company employs you, you have to have a background, as I said, of your education. Like I can share briefly how I got my first job in the aviation. Previously, I was working with Halotel, and since I had a passion on the aviation, I contacted a certain company called Tanzania. It's doing the chartered, the small aircrafts, the Caravan, Cessna 208, the Beechcrafts, and some sort of the small planes. I did my application there, and they interviewed me, knowing that I have a background in electronics and that I can do the avionics well. So after I did the interview and they accepted, I started working as a technician. They don't recognize you as an engineer without a license. So I started working as a technician for 4 years. After 4 years, then I was eligible to go to TCAA for the license exams. So I went to TCAA and I did that. I got the license. After I got the license, then now it was recognized as the maintenance engineer. I hope I've answered Isaac Mwasambela's question well. How will you respond to what? Sorry, Nomele, I don't get your question well. What happens if you are a pilot and encounter a drone along your predefined flight track? How and what will be your response? In Tanzania, all drones are operated under TCAA also. You're not allowed to fly your drones without an approval from TCAA. So TCAA will give you an approval to fly your drones. Then it will know your location. TCAA needs to know your location and where you're flying so they can allow you, knowing that there is no plane on that point, and then you're free to fly. So it's not possible for a pilot to encounter a drone along his flight. Okay. Okay, another question. Have I answered your question, Domele, properly about what happens if the pilot encounter with a drone? It's not possible for a pilot to encounter a drone during flight because even the drones are operated under TCAA regulations.
I may say somehow.
Okay. Okay, any other question? Okay. I think from that I've explained until how to become an avionics engineer from the previous explanations. I said to obtain this license, you need to have 4 years of experience working in approved maintenance organization or 2 years of experience in an approved maintenance organization if you went to an approved training organization. Then TCAA will provide an examination to test your knowledge and skills before giving you the license. And I said, this license is the one that gives you the authority to release an aircraft back to service after any avionics maintenance, inspection, or repair is done on the aircraft. Okay, we have one new message here. As the maintenance engineer, do you have any pilot skills? Some sort of, but you're not allowed to fly the plane. You can have the pilot skills, you know how to make the plane fly, but you're not allowed to do that according to the regulations. And you cannot dare to do that because the moment you do that, your license is at risk. Is heavy rainfall can cause any challenges during flights? Yes. Heavy rainfall is not good. So as I said before, we have the weather radar antennas on the plane. This is to show you the weather of where you're going. If it's really heavy raining, then aborting flight is allowed, or aborting landing is allowed. You cannot land if it's heavily raining. So it causes challenges, and if it's really severe, you're not allowed to land or to. During cruising is not much of a problem. It's not much of the problem during cruising. Mostly it's during landing, because you need to see your runway clearly. So if you don't have the clear vision of your runway, then you're not allowed to land. This is to make your flight safe. So heavy rainfall is really a challenge, and you have to see how to deal with it. Any other question? Salary offered. Wow, that's beautiful. Good. The aviation industry pays well. It pays well. I cannot say the figure because it depends on the employer, but if you work abroad, you'll be paid better than here. If you go in a certain country as an expat, you'll be paid well, really well. I think it's one of the most high paid industry in the world. I think so. In Tanzania, because of siasa and so forth, the payment is not that good, but it's better. It's better compared to other fields. Any other question? Any other question? Okay. So I think on that I answered how to become a maintenance engineer. Then I'll go to the challenges we face in the aviation industry. There are challenges as in any other industry. We also have challenges here. Sustainability is one of the challenges. Sustainability has 3 dimensions: the environmental, economic, and the social. We also have the challenge in technology. The technology changes very fast. And as a personnel, you really need to change with it. As the technology changes, you need to change also. So it's also another challenge. Most people are left behind with the technology. So it's another challenge. We also have the safety and security. As your previous questions, you were asking on the risk we take. The safety and security issue is a key, actually. I can say this needs to be a key. You need to work with it every good day. So one mistake, one goal. So it's a challenge. It's really a challenge. Also, we have fewer maintenance facilities. Like in Tanzania, the maintenance facilities we have is the Air Tanzania, the Precision Air, the Tanzania, the company I started working with, Regional Air in Arusha, Coastal Aviation. You can even list them. They're very few. You can even list them. So the maintenance facilities are few, and yet the number of people who needs to work on the plane is growing every day. So it's another challenge. Also, we have a challenge of the shortage of skilled staff, pilots and technicians. We are trying. The industry is growing now in Tanzania, but we really have this challenge of the skilled people. We are working with people from VETA and other colleges in Tanzania, but the number of the skilled staff is not adequate. It's not enough. So we really have the shortage of the skilled people. We lack enough competent personnel. And also we have the availability of parts after the corona pandemic, the COVID-19. The spares have become a problem. Every now and then you hear that our engines are not running because we don't have the spares. A certain plane is not flying because we don't have the spares. This is all the results of the corona or the COVID-19 pandemic. So these are some of the challenges we have. I'll answer the question here. Air Tanzania employment are permanent or short contracts. You'll have a short contract of about 5 years, then maybe another 5 years, then thereafter, as they're observing you, they can give you a permanent contract. It's a matter of time. You are just not given a permanent contract after you join. As you join, you'll be given a short contract and they'll be observing you to a certain number of years, then they'll give you a permanent contract. Okay. This is the conclusion. I shared the references, but before I go to the conclusion, I would really like to answer your questions. We have about 20 minutes left, so we can use this time to answer your questions. Any question you have, I would really like to answer them. I welcome questions. Any question, please feel free to share, feel free to ask. Have you taken any short course certification before joining in Air Tanzania? I was doing my EASA examinations in the United Kingdom and Dubai, but this is for international aviation. It's called the EASA Part 66. I was doing these exams for my EASA license, which is then also maintenance license, but this is for international duties, not for the local for the local authority. It's the same exams as I was doing with PCAA, but the EASA is under UK Civil Aviation, and they give you a license that allows you to work all over the world. It's an international license. What is the safety while working in the industry? We have the safety maintenance manual, safety manuals that we use that leads us or give us the way forward for our day-to-day activities. So while working in the industry, the safety measures or the safety parameters you'll be given by your employer. So if it's Air Tanzania is responsible to give you the safety keys or the safety measures to take while doing your day-to-day activities. So if the manufacturer is the one, if the company manufacturer the plane grounded the production of spare parts, you have to ground the plane too. Exactly. If the part that is defective is a no-go part, the plane needs to be grounded. You cannot fly the plane with a no-go item defective. So if the spare that you need is not available at the time, and the plane cannot fly with it, the airplane is grounded. It doesn't matter how small the part is. It doesn't matter how small it is. If in the minimum equipment list, it is mentioned that you need to have that spare on, active, operating, and it's defective, it's a no-go. The plane needs to be grounded. Did I answer you correctly, Isaac? Does your work require you to wear those fancy overalls, safety boots, and working with spanners compared to mechanical engineers? Of course, yes. You have to have the safety equipment, the PPEs. You put them on, yes. You have to put on the overall, you have to put the safety boots, you work with the spanners, yes. Because you open parts of the plane and we work with it. So we put on. Though at times we also have decent outfits, like the one that I wore on the display on the okay, the one that you were sent. It's also part of our uniforms. we put on them at times, and at times we put on the PPEs. We're working in the hangar. So we have both. We have the smart ones and we have the overalls. What are the key differences between designing commercial and military aircraft? First, the military aviation is very different from the civil aviation. The military aviation operates differently and does not follow the TCA regulations. They have their own regulations, their own designs according to their own manufacturers, according to the specific use of that military aircraft. So there are so many differences between their planes and ours. Ours are designed for commercial. They need to be good looking also to the passengers. So there are major differences between our designs of the commercial planes and the military aircraft. From Fatuma Masakia, to get the chance to work as an internship, do they consider GPA or just the knowledge you have is enough? I'm sorry, I never applied for the internship, but I think the knowledge you have is enough. The knowledge you have is enough because that depends with the employer or the operator and what the operator needs. But I've never heard of them considering the GPA. I think they consider what you know because you'll be interviewed on what you know. Then if you fail in the basics, then you won't even get the internship, I think. So you need to have the basics of, like if it's electronic parts, you need to have the basics of electronics. If it's the mechanical parts, you need to have the basics of the mechanical. Apart from the pilots, from Hassan Kasim, apart from the pilots, which professions are more needed in the aviation industry? How can we meet those opportunities as ICT graduates? Okay, apart from the pilots, the avionics engineers are really needed. We have very few numbers of avionics engineers. And as ICT graduates, you have the basics of the communication, I think, which is good to start with. So you present your what you know to the employer, and the employer will assess you and see if you qualify to start working with them. They'll give you the basic training of the aircraft maintenance, and from there you have a starting point. From there you have a good starting point. I would like, from Prosperous, I would like to know on the issue of annexes for an aircraft maintenance engineer. Are you concentrating on specific annexes, or are you supposed to know all of them, 19 annexes? Good, Prosperous, I like this. Seems like you went so deep on this. We really have the 19 annexes, and depends on your part. Like us, we deal more with the annex, the airworthiness, the personal licensing part. We have some. We don't take all the 19 annexes because we have the aerodromes, we have the operation part, we have the maintenance part, we have different parts in the aviation. So each unit or each part in the aviation has its own annexes to deal with. But you need to know the annexes, what they do or what they demand. Good, I like the question. I really like it. Then I have another question here from Isaac Masalemba. For example, Boeing plane cannot choose spare from other company like Airbus or Bombardier. Yes. Boeing plane have their own spare parts. Bombardier have their own spare parts, and we have the suppliers. We are given suppliers by the manufacturers, the approved suppliers, to provide us with the spare parts for specific plane. So you cannot choose the spare from Bombardier to Boeing. Even the light, you cannot choose it. Just the light, you cannot choose it. Have I answered you well, Isaac? Any other question? Any other question? Okay, from Kenson Walter. Specifically to piloting, can an ICT graduate become a pilot? What are the steps? Okay. I think an ICT graduate can become a pilot because I think being a pilot determines on the course you studied in your high level education. The PCM, PGM, you can all go for the pilot studies. So the steps, you only need to go and register yourself in the institutions that provides their pilot courses. Like in Tanzania, we have one institution in Julius Nyerere International Airport, Terminal 1. You can visit that place, you can see the instructors, you can talk to them. They can give you a way forward to start your courses on becoming a pilot. You pay your fee and you start your classes. Okay, Kenson? So you're on the right track, but you'll have to go for the pilot courses also. You have to go for the training. Then after the training, you have your experience. You have to work in the field to get the hours, the flying hours. Yes. Any other? We have about 14 minutes left. We have about 14 minutes left, so I take a few more questions before we wind up. Okay, from Jiduta. With the trend of the AI, from the Jiduta Magari, with the trends in AI, is there any application in avionics? Dear one, we're not using artificial intelligence in any part of the maintenance. In any part of the maintenance, we're not using that. So in every task that you're doing in avionics, you have to follow what the manuals say. Only that. There are no applications for AI. I don't know. I've never tried, but maybe yes. You can also try seeing in the internet, but in the field, no, not at all. It's not allowed. It's strictly prohibited. We're not using the AI in any part of the maintenance. We also have another question from this one person. What is the minimum age requirement for the ICT graduate to be allowed to join the pilot training courses? I think 18 years of age is enough. So if you're a graduate with 18, it's enough. You're allowed to join the pilot training courses. If not 18, then 21. But I think 18. I'm not sure, but maybe 21. Maybe 21, but I suppose even 18 is enough. Okay. As an air traffic maintenance engineer, are you involved in the ATSEP training? Does the training differ from air navigation engineers? Yeah, the training differs from air navigation engineers. The air navigation engineers do a different training from us, from the maintenance engineers. We're not involved in the ATSEP trainings. From Kensen Walter, can a pilot do also some maintenance, avionics engineering, or he or she has to be a pilot only? There are things that a pilot is allowed to do in part of the maintenance when the pilot is out of base. When the plane is flying to a point that is out of the base and there is something that needs to do a maintenance, the pilot is allowed to do the maintenance and sign it. Only if the maintenance does not involve using maintenance equipment or maintenance test sets. As long as the maintenance does not involve using test sets or test equipment, then the pilot can do the maintenance and can sign to release that aircraft to service. From Somagile, are there full funded sponsorship and scholarship for aviation engineering courses in Tanzania? Once in a while, I see from TCAA that they are sponsorship, but they come with time. It's not every time. So when they come, people take a chance, but it's not always. At times, yes, TCAA or any sponsors or the school for the scholarship contact TCAA, and the TCAA announces for the sponsorship and the scholarships, and people take the chances. Okay, Mr. Magile. Good, thank you. Yes, Domele, do you have anything to say?
Yes. As to most of we students taking like computer engineering and telecommunication interested in avionics, and radio frequencies, we are much eager to participate in the activities of navigation. I mean, the civil aviation industry, but the main challenges is we are not getting those chances. You may find yourself applying for the internship, the PT, practical works, but you are not going to get that chance to go there. So my ask is, if you are in that position of helping UDism students, especially ICT ones, recommend them to get those practical trainings, maybe. Yeah.
Okay, I can assist for people who want, but I speak to the HRs. I'm not the one giving out their fields or the practical fields. So if the person is interested, I can ask the HRs if they can allow the person to come for the field. And it's not only Air Tanzania. You can come to the airport, request to visit some of the companies like Tanzania, Precision, or Coast Aviation. You can speak to them and tell them that you're the students and you want to do your practical trainings. And if they have the chances, they'll surely give you. Because I've ever seen a person from mechanical engineering in Tanzania. He came to do from UDSM, from University of Dar es Salaam. He came to Tanzania for practical training in his second year, I think, from mechanical engineering. I don't remember the name, but I remember one person from mechanical engineering in Tanzania. So before the time of your practical training, at least 2 months before, it's best to come and visit the company and request for your practical training, and they'll schedule for you to start your training at your time that your training starts. So if I'm in the position to assist, I can assist. I shared my numbers so a person can call me and we can see if there is a chance or there is anything I can assist, I can assist. Okay?
Yeah, thank you. Thank you.
Thank you very much. Yes, we have 5 minutes to wind up. I can take 2 more questions as I'm winding up here. I shared here the references. The aircraft electrical system, it's a book by EHA Pallet. We also have the instruments integrated system also by the same EHA Pallet. We have the aircraft radio system by J. Paul. If you get a time, you can just read these 3 books and you can get a picture at least of what is done or how the systems work. There are a few links, just 2 links here, but you can search as much as you can, get to the internet, write anything you need to know about aviation, write anything you need to know about avionics, write anything you need to know about aircraft maintenance, and you'll have more information that will guide you to a certain good point in this field. Please, can you share your slides with us? Okay, I will share these slides with Dr. Baraka Maiseli, and I think you can I will share it with him. So feel free to ask him or yeah, I'll share it. I'll share it with Dr. Baraka. Okay, I would like to acknowledge my coaches, Dr. Baraka Maiseli, Dr. Mwambela, Dr. Shante, Dr. Mwamilala, Professor Kundaeli, and so many others. They really coached me well to this point. They played a big role in my journey in electronics and where I am now. So I really thank them for the big contribution in my field. And thank you very much for your time. Thank you very much for your concern, your interest in aviation. You can contact me if you have any query. Feel free. In the aviation sector, is it allowed to work as an aircraft maintenance engineer as well as a pilot? Oh, no, you have to choose one field. There are people who are aircraft maintenance engineers and there are people who are pilots. But you cannot do both at once for safety reasons. You cannot fly the plane, you maintained it yourself. Okay, so it's not allowed to do it at once, but you can have both and you can use it differently at different times. Okay. Okay, thank you.
Hello.
Yes.
Hello.
Hello.
Thank you very much, Halima, for such a wonderful presentation. I was listening, I was on the road, and I really learned a lot from you and from the presentation.
I truly appreciate it.
Yeah, I think even my a few of my colleagues that joined, and even students, I think they also enjoyed a lot.
Thank you.
So let's keep in touch, and for other logistics, I'll check with you.
All right.
Also, I was recommending, because we have a separate group where members of this group joined. So I was thinking of extending the discussion from Zoom to the group. If you are not in that group, if you would not mind, we may add you. And if the student has any other question apart from, after this meeting, he may ask in that group. If you're comfortable with that, then Hassani, are you there? Hassani?
Yes, Professor, I'm here.
Yeah, so you may add the presenter to that group. I think, students would have lots of other questions to ask.
Yeah, I know.
Okay, Professor.
Okay. So otherwise, thank you so much, and thank you, students, for joining. Let's hope that we're going to have more of these sessions in the future. Thank you very much.
Thank you very much. I truly appreciate.
Okay, bye-bye.
Bye-bye.
Zamazoni